Hello everyone, welcome to SQL Maestros. I am Satya Ramesh. Today we are going to discuss about nested loop join in SQL Server. So what is nested loop join? So in SQL Server, we have three physical join operators exist. So they are nested loop joins, merge join and hash join. So these three are physical join operators that are there existing in SQL Server. So whenever you perform any logical operation using inner join, cross join, outer joins, or else cross apply, outer apply, so that means basically we are joining two data sets or multiple data sets. So whenever you are joining multiple data sets in SQL query, we represent in logical way, but inside SQL Server these two data sets has to be joined physically. So physically data can be joined only in three ways. They are nested, merge and hash. Today we are going to concentrate only on nested loop join. So let's go ahead and see few more facts about nested loop join. So nested loop join, how it will perform. So if you observe this execution plan right below, so this is the nested loop or nested loop join operator icon. So we have one input and we have second input. So upper input is called as outer table and the lower input is called as inner table. So whenever SQL Server has to join two physical data sets and SQL Server decide to perform using nested loop algorithm, this is how it happens. It will compare each row from outer table with each row from inner table. So if you observe the first bullet point, compares each row from outer table to each row from the inner table and looks for the rows that satisfy the join predicate. This is what SQL Server is going to do. So usually whenever SQL Server is selecting outer table, it always selects smallest table as outer table so that it is easy to look up into inner table. So if I have few records in outer table, it is easy to look up into inner table. This is what happens. So this operation doesn't require any memory, but if you observe, if the data sets are becoming huge, then this won't scale very well, because if every row from outer table has to be checked with every row from inner table. So if the data sets are very big, this won't scale out very well. This is the one of the disadvantage of nested loop join. Let's go ahead and see this nested loop join with one more basic example. So consider this. We have a table A having ID column having 4 records, and we have a table B having ID column, it has 6 records. So whenever you want to join these two data sets, say for example you have said inner join. This is the query to join these two data sets, and assume that SQL Server has decided to perform nested loop join to actually join these two data sets. So how this algorithm going to work? First, SQL Server will select smallest table as outer table. In this case our smallest table is table A because it has only 4 rows when compared to table B. So table A is our outer table and table B is our inner table. So SQL Server will first take row number 1 and compare that with the row number 1 in table B. So, and as our operator is equality operator, this will check for equality or not. 1 is not equal to 2, so this row is not correct. Then again so this is not correct. Again SQL Server go and select with 1 equal to 4, not correct. 1 equal to 6, not correct. 1 equal to 7, not correct. 1 equal to 9, not correct. But when it compared to 1 equal to 1, SQL Server knows that 1 is equal to 1. So it is correct. So it will give the final output as 1. So this is how SQL Server performs nested loop join. Take one row, compare with all the rows in the inner table. Take another row from outer table, compare all the rows from inner table. So if you take this 4 and it compares all the rows with our inner table, so 4 equal to 4 only once, so the output is written. Similarly 5 is not there in this table, so output will not be there, but 7 is there, so output is 7 here. So this is how SQL Server performs nested loop join whenever you tell SQL Server to join two data sets. So these are the few facts about nested loop join. So when the nested loop join is good, whenever the inputs, relatively small inputs with an index on the inner table on joining key, then SQL Server will obviously choose for nested loop joins. These facts are most frequent options, but this does not happen always. This is the point to be noted. So when it comes to concurrency, so it will support large number of concurrent users, but sometimes when the tables are very big, it slow down the performance of your SQL Server. And the third point, if you see, is it the blocking operator? No, it won't block. It will process each and every row continuously. Whereas hash join is a blocking operator, which we discuss in later videos. And is it required any equi join? Not necessarily. If equi join is there, it will perform. Even though equi join is not there, SQL Server will still use nested loop join. This is the case when we use cross joins. Cross join didn't have any equality predicate. For that matter, cross join do not have any predicate, do not have on condition. So whenever you perform cross join, SQL Server has no other choice other than performing nested loop join. So equi joins are not necessary. It won't use memory and it won't use StemDB, and it is not necessarily requires the data in sorting order, as we have seen in earlier example how nested loop join compares one data set with another data sets. So if algorithm is in such a way so that it doesn't need data in sorting order. So these are the few facts about nested loop join. Without any delay, let us go back and see few examples in action. Let us see the examples. So right now I'm using AdventureWorks database. So let me create few tables, 2 tables, and I have inserted some data into it. And if you observe, these are the 2 tables. So table 1 and table 2. So these are the 2 tables available now, and let me perform a simple cross join. So this is the simple syntax to perform cross join, and let me turn on execution plan. I'm performing a cross join between table A and table B, and if you observe the execution plan, it performed nested loop join. If you observe this, SQL Server is performing nested loop join. The thing is very clear. Whenever you perform cross join between 2 tables, SQL Server will always use nested join, because what cross join will do? It will perform a Cartesian product between 2 data sets. If table A have 3 records and table B have 5 records, the output will be 3 into 5, 15 records. So whenever you are telling SQL Server to match each and every row from table A with each and every row from table B, so this is exactly equal to physically performing nested loop join, as we had discussed in earlier example. So whenever you tell SQL Server to perform cross join, it will always perform nested loop join. There are few exceptions. Whenever you put up a where class to match up the cross join to make it equal to inner join, then internal query tree structure will change. So SQL Server can use other join operators other than nested loop join. So there are such cases, but if you simply put up cross join and without mentioning any where condition, SQL Server will always perform nested loop join. In some cases, if you put up few conditions which are not necessarily is equal to inner join, then SQL Server will still use nested loop join. So this is one example about nested loop join. Let me go back to another example. So I have this database called SQL Maestros Production. So I have created this database, and I have created schema, and I have created a table called SQL Maestros Production.hols. So this table have 4 columns in it. I have created a cluster index on column 1, and I have created a non-cluster index on column 4. So let me show you that. So before going to that, I have inserted 1000 records into that particular table. So we have a table having 4 columns and 1000 records. So I have created a clustered index on column 1, and I have created a non-cluster index on column 4. So we have a table with 4 columns with 1000 rows, and column 1 having clustered index and column 4 having non-cluster index. Let me execute this simple query. So what we are doing in this query, we are asking for all the columns from the table where column 4 is equal to this particular numeric value. So let me execute this and turn on execution plan. So I've executed this, and I have to, if you go to execution plan and observe what is going on, SQL Server is seeking on column 4 because we are searching on column 4 where our where condition is on column 4, and we are asking for all the columns. So we have column 4 in non-cluster index, and we have just because we have a cluster index on column 1, by default all non-cluster indexes include clustered key column. So this non-cluster index also has column 1. But to get column 2 and column 3, SQL Server is doing a lookup into clustered table. So to get column 2 and column 3, if you hover over the key lookup column, and if I zoom in and see this, to get column 2 and column 3, SQL Server is doing a key lookup. So this will happen for every row written by outer table here. This key lookup will happen. So if you compare this with the earlier example, every row written by the outer table, SQL Server will do a key lookup into cluster table. So and performing a joining operation. So whenever this kind of algorithm happens, SQL Server will always select nested loop join. So this also will not scale very well if number of rows written by the outer table are huge. So for example, if outer table is returning millions of rows and performing that key lookup million times is very expensive, sometimes SQL Server will go ahead and do a scan instead of this seek. So this is what happens whenever you do this kind of an operations. So how to, in this case, this is fine. When it becomes worse, so how to avoid this nested loop operation here? Just go ahead and create a covering index that includes these two columns as well. So let me drop the existing index and create the new index again with included columns. So this makes our index as a covering index. Let me execute the same query again. Now if you go and see the execution plan, we do not have a nested loop join, we just have a seek which is faster than the earlier query. So this is one of the example how you can avoid nested loop join by creating a covering index so that performance will get improved. So let me show you one more simple example, which is the last one. So what I am doing here, this example is related to table variable. So I am creating a table variable. So before that, I'll just show you one thing. So what I am doing is I have a table called production.product in Adventure Work database. So if I execute that, I have a table having 504 records. So what I am doing is I am putting up all these 500 records in a table variable. Sometimes we are doing it, right? So whenever we are writing the store procedures, so we'll take out the data from base table and put it into temporary table or table variable and then join the table variable with any other table to finally get the output. So these operations we do because we are performing join on a particular data set. So if you get the data into table variable or temp table, so these data gets stored normally in tempdb. Basically when you perform when you create a table variable, data gets stored in memory, and if memory is not sufficient, it will get spilled to disk. That will obviously happen, but idea is very simple. These things we are doing just because this operation will happen either in memory or in tempdb. Tempdb will not necessarily write everything into the log. It will write very few things into the log, so it is faster. So because of that, we create these table variables and temp tables. So for that purpose, I have got all the data from this production.product table into a table variable. So what I'm doing here is I'm creating a table variable. This is the table variable definition, and inserting all the records from production.product table into a table variable. And finally, I'm performing join operation between our table variable and sales.sales order detail table on product ID column. So if product ID from sales order detail is equal to product ID from table variable, then we'll get the output. So this is what I'm going to do. Let me execute this entire operation in single stretch. So execution plan is on, and let me execute this. So our output will get close to 1,21,000 records. So it may take up to 8 to 10 seconds in my machine. So our output is about to come. Yes. So if you see, output is this many rows. So let me go ahead and see the execution plan here. Click on execution plan, and this is the plan for selection. If you see, if you observe this particular plan, what is going on? As we already know, whenever SQL Server decides to perform nested loop join, SQL Server will select smallest data set as outer table and largest data set as inner table, relatively largest and smallest. So when it comes to table variable, table variables estimated number of rows are always 1. So whenever you are using table variable in joining condition, just because the estimate number of rows is always 1, SQL Server will select table variable as outer table, just because it's easy to perform lookup one record into another data set. But in real, if you observe the actual number of rows are 504 now. So what happening here? Just because table variables didn't maintain statistics internally, so our estimated number of rows are always 1. So just because of this nature, SQL Server will try to use nested loop join whenever you join two datasets and one dataset is table variable. This is very expensive if at all the number of rows are more than 20,000, 30,000 and millions of rows. So if the datasets are very huge, table variables will not scale very well. So whenever you are using table variable in join condition, SQL Server will select nested loop join. This is going to be very expensive. So instead of table variable, you can go with temporary table whenever the datasets are more. But if you want to still go ahead with table variable, just use option recompile hint, so that estimated number of rows will increase by few number depending upon the cardinality estimation. So this is all, friends, about nested loop joins. So let me go back to my slides again. Thank you for your time. You can follow me on Twitter at Satya Ramesh 230, and you can also follow SQL Maestros at @SQL Maestros. Thank you for your time. See you in another video.